Okay, so we're going to pick up where we left off with finding area under a curve, but this time our data, or this time our information is in the form of a table of data. It says you and a friend are driving along a twisty stretch of dirt road in a car whose speedometer works, but whose odometer is broken. Now, an odometer tells you how many miles you've driven. To find out how long this particular stretch of road is, you record the car's velocity in 10-second intervals, with the results shown in the table below. Estimate the length of road by averaging the left ram and the right ram sums. So, as we look at our data, we're talking about a car that is in motion, and it's in motion for, the data is for 120 seconds. So notice that the velocity, you can see that the velocity values are in the table. And so we don't have to graph this. I mean, if you want to get an idea of what the data looks like, you can, but it's really not necessary. When we want to find a value of area because we're wanting to find the length of road, then we've got everything we need right here in this table. So first, if we were to graph this, and I'm not, but our data, our x and y axis would be, x-axis would be time, and the y-axis would be velocity. So this curve, whatever it may look like, we would want to divide it into multiple rectangles. Well, the cool thing is we can actually look at our time intervals, and we can determine, if you notice that these are in 10-second intervals, so that helps things because that tells us that the width of each rectangle would be 10. So we don't have to do any kind of calculations. We can see where the time is increasing by 10 seconds. So that means the width is going to be 10. So now we're wanting to use left ram. So these would be the values. V of 0, this would be V of 0. So V of 0 equals 0. V of 10 equals 44, and so on. Well, these are all of our heights, because remember, we get our heights of the rectangles from our velocity. So left ram, my height of the first rectangle will be 0. So we're going to have left ram area equals 10 for the width. Scoot that up a little bit. And now I'm going to multiply it by the sum of all the heights, starting with 0 and stopping with the 30, because 30 would be the last left endpoint. So it would be 0 plus 44 plus 15 plus 35 plus 30 plus 44. Have I skipped over that? No, plus 35 plus 15 plus 22 plus 35 plus 44 plus 30. So I hope I've got all of those in there. When we add these numbers up, we actually get 349, and we multiply that by 10, and we get 3,490 feet. So in this 120 seconds, you guys have traveled 3,490 feet in using a left ram approach. We were also asked to find the average or find the length of the road by averaging the left ram and the right ram. So I have the left ram. Finding the right ram is really not going to be too difficult because the first height using the left endpoint was 0. So all we have to do is take our left ram value or our heights and add 35 and then multiply by 10. So my right ram, my R ram area will be 10 times whatever the left ram was, which was 349. I will add 35 and that will give me 3,840 feet. So the left ram gave us 3,490 feet. The right ram gave us 3,840 feet. If we average those two together, I'm kind of all over the place and I'm sorry. So the average is going to be the sum of those two, 3,490 plus 3,840 divided by 2, which is 3,665 feet. So determining the length of road that was traveled in this 120 seconds, which is what, 2 minutes, the average using the left ram and the right ram was 3,665 feet. So you can use a rectangular approximation method when your data is in a table form or tabular form as well. In fact, I think it's a lot easier because you don't have to find those values. You don't have to find the heights plugging in values for functions. So let's look at the next one. The next one that I have is, what does this say? Okay, it says the speed of a runner increased steadily during the first 3 seconds of a race. Her speed at half-second intervals, which is nice, that's going to be helpful, is given in the table. Find the lower sum and the upper estimates, or lower and upper estimates, for the distance that she traveled during these 3 seconds. So let's first, okay, we know that the time is in seconds. I did not include this. Her velocity is going to be feet per second. So if I want to find the lower estimates for her distance, that would be the left ram. I need to know my width, or her width rather, of each of these intervals, and you'll notice that time increases by 1/2. So my width is going to be 1/2, and so all I have to do now is multiply that by the sum of all the heights starting with the left endpoint. So starting with 0, add 6.2 plus 10.8 plus 14.9 plus 18.1 plus 19.4. And then what you get there is approximately, when I add all of this up and then multiply that by 1/2, I believe we get 34.7. So using the left or the lower estimate gives us that the runner traveled 34.7 feet during the first 3 seconds. So that's the lower estimate. Now let's find the upper estimate, which would come from the right ram. And our width is still going to be 1/2. So it's 1/2 multiplied by. So once again, just like the last example, since our first height was 0, we can just take this width, not width, but this sum, which I didn't actually add that up. I don't know what the sum of that was, but we'll take the 6.2, I guess I need to do this, 6.2 plus 10.8 plus 14.9 plus 18.1 plus 19.4 and add the 20.2. And when you add these and then multiply by half, your upper limit or upper estimate is going to be 44.8 feet. So using an upper estimate, using the right ram, the runner traveled 44.8 feet during the first 3 seconds. So again, we use table in the data. We use table in the data to determine the length of, or the distance that she traveled. Okay, so why don't you pause the video and why don't you go through and find the distance traveled in feet by a dog during the first minute, the 60 seconds, using a midpoint Riemann sum with 10-second intervals. So let me kind of give you a little heads up. So notice that each of these intervals, the time is increasing by 10. So 0, 10, 20, 30, 40, 50, 60. Now notice that it tells us to use a midpoint Riemann sum. Well, the times are increasing nicely by 10. The midpoint between 0 and 10 would be 5. The problem with using 5 as the midpoint is that we don't have data for the velocity at t equals 5. But here's the nice thing. We can actually have one interval going from 0 to 20, and the midpoint would be 10. And then we have another interval, 20 to 40, with the midpoint being 30, and then go from 40 to 60, your midpoint would be 50. So for this data, why don't you take a minute, pause the video, and see what you get for the area, which would give you the distance traveled by this dog during the first minute. And then we'll check together. Okay, so here we need to determine the width of each interval. Now notice that, remember, we're not using a width of 10. This first interval is from 0 to 20, and then 20 to 40, and then 40 to 60. So we're really going to have 60 minus 0 over, or divided by, how many rectangles? Well, we have 3 rectangles. So that's really going to turn out to be a width of 20. So if we want to find the area using the midpoint approximation method, then we're going to take our width, 20, and multiply it by the sum of the heights of the 3 rectangles using the height at each of the midpoints. So the midpoint of the first rectangle is 10, so the height of that rectangle at t equals 10 is 16. So I'll take 16 and then add. The next rectangle goes from 20 to 40. Its midpoint is 30, and the height at 30 is 43. And then the last one would be the midpoint of the last rectangle, which is at 50, and the height would be 72. So when we take 20 and let's see, that adds up to be 16 and 43. That's what, 59, and 59 plus 72, that's 131. So this value turns out to be 2,620. So what that tells us is the dog traveled 2,620 feet during the first minute. So using data in a table can be pretty straightforward when you want to find area under a curve that will give you like total distance. So anytime you have data that is velocity, then the area under the curve will represent total distance or total change in position. So we have one more example in our notes, but I think I'll stop and we will try to look at that example in class. So that wraps up finding area using a left ram, a midpoint ram, and a rectangular ram. The next video in the next lesson is going to be a different method, which we will use the trapezoid approach. So we'll talk later.